Hello students, I am Kamal and in this video we are going to talk about the differentiability of a real valued function and we are going to see what are the conditions which makes a function differentiable. Okay, so let's start. Let fx is be a real valued function of x which is defined in an open interval a comma b and c is a point which is in between a and b. And apart from this, fx is a continuous function. Okay, if fx is a continuous function, we can very well able to draw it on a coordinate plane. Okay, so this is fx and this is x. Let's suppose that this is the graph of fx. Okay, first we are going to discuss what is rate. So first we are discussing what is rate. So rate gives us information how much one quantity is changing with respect to another quantity. Like we have to see the rate of how fx is changing with x. So let's assume that this point is x1 and this point is x2. So the value of x at x1 would be fx1 and this would be fx2, and if you mark this point, this point would be x2 comma fx1 x2, sorry, and this point would be x comma fx1. Now we want to find the rate between x1 and x2, how fx is changing. So the rate would be equals to f of x2 minus f of x1 upon x2 minus x1. By calculating this value, we can get the information how fx is changing with x in between x1 and x2. Okay, here for calculating this rate, this change would be large or even small. Okay, now what is differentiation? Differentiation is also a rate. By differentiation, we will also going to calculate the rate of change of this fx with respect to x. Okay, so differentiation is also gives us rate how a quantity changes. Okay, but the difference between this rate and this rate would be that differentiation is the change that we calculate in differentiation is for infinitesimal change. Infinitesimal change. Now, what do you mean by infinitesimal change? We are going to understand this infinitesimal change by decimal. What is decimal? Okay, let us take a 1 centimeter line. This is, assume it should be equals to 1 centimeter, and this 1 centimeter line is divided into 10 equals parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, this is decimal system. Okay, we are going to understand infinitesimal change by this decimal system. So in decimal system, we have a line and we have divided it into 10 equal parts. In infinitesimal change, we are going to use the same line, this line, the same line, and we are going to divide it into infinite parts. Okay, in decimal system, we have divided this into 10 equal parts, and in infinitesimal system, we are going to divide this into infinite parts. So we have divided into infinite part, and for one part in this infinitesimal chain, we are going to calculate the rate, and that rate gives us differentiation of that function. Okay, so what was the benefit of this infinitesimal change? This infinitesimal change will give us the power to calculate the rate of fx with respect to x at any point. At any point, you can able to calculate the rate of fx with respect to x at any point by the use of infinitesimal change. Okay, so how this infinitesimal change is going to define the differentiation? Okay, now we are going to see that. So I'm rubbing this. Now limit is used for calculating the infinitesimal change. Okay, we have taken 3 points on this curve of fx, a, b and c. We have joined this line ab, this chord ab and chord bc. Okay, and we are going to calculate or we are going to see the differentiability of fx at point b. Okay, which is at this point. Okay, now we have taken another point at f x plus h, and here, which is somewhat greater than this x, and this point is somewhat lesser than x. Okay, so at x minus h we are getting the value f x minus h, and at x plus h we are getting the value f x plus h. Okay, so if we are able to find the slope of this chord AP, slope of chord AB, it will be equals to f of x minus f of x minus h upon x minus h. Okay, if we substitute the minus sign inside, this will become minus and this will become plus. Okay, so this will get cancelled and this will remain. Okay, if you calculate the slope of chord BC, that will be equal to f of x plus h minus f of x upon x plus h minus x. Okay, this will get cancelled, x and minus x, so h will remain only. Okay, now at point B we can see that there is a tangent at point B, which is PBR. This PBR is a tangent to fx at point B. This is very important. Now coming to this infinitesimal change. Okay, we have a line and we have divided this line into infinite part, and if we take one part, it will be infinite part में divide कर दिया, and one part of it would be infinitesimal element. Okay, now for defining that infinitesimal element, we are using the concept of limit, because we cannot able to calculate values which is something like this, but we can use the concept of limit. Okay, this limit h is tending to 0, we can say that this is an infinitesimal element, or from this we can able to calculate the infinitesimal change. Okay, if we take this change for very small value, it will remain the slope of the chord AB, or it will remain the slope of the chord BC. Okay, so if we take the infinitesimal change, we are using here limit h tending to 0, and here also limit h tending to 0, which will also give us the slope of chord AB and the slope of chord BC. Now what will happen if we take this infinitesimal changes? Okay, if this value is very small, like infinitesimal element, this will approaches to x. Okay, and this x plus 1 is also approaches to x. Consequently, the length of this chord also shortened by using this infinitesimal change. Okay, so this AB and this BC will represent the slope of this tangent PBR. If we take this infinitesimal change, okay, if we take this limit, then this AB and this BC will be equals to this chord, or we can say that the slope of AB and the slope of BC would be equals to the slope of PBR. Okay, consequently, slope of AB would be equals to the slope of BC, and that will be equals to slope of tangent at P, which is PBR. Okay, so both this slope will be equal if it is for infinitesimal change. So we are getting a very important conclusion from this. If this is so, then limit h tending to 0 f of x minus f of x minus h by h, it will be equal to limit h tending to 0 f of x plus h minus f of x upon h, and that will be equal to the slope of that tangent at point B, sorry, and then slope will be equals to dy by dx. So we are drawing very important conclusions from this relation. First is fx should be a continuous real valued function. First of all. Second, there should be no sharp edges. If a function is differentiable at any point, like we are going to calculate the differentiability of a function at point B. So at point B, the function should be a continuous real function. Okay, means continuous means there not be any loophole or any breakpoints. Okay, and there should be no sharp edges, which means that the function like this, at this point the function is not differentiable, at this point. This function is not differentiable because of this sharp changes. Okay, so this is all about the differentiability of a real valued function, and what are the basic needs for the function to be differentiable. It should be a continuous function and there should be no sharp edges, and if a function is differentiable, then this limit holds. Okay, then only that function can be differentiable. I hope that this video will be helpful for you.